Hi. Well, this week we are going to do the Southern Ocean, and here it is on Google Earth, and it's pretty much the boundary is 60. This circle right here, 60 degrees south, which goes around, and then at the coast of Antarctica. It's just the open waters around Antarctica, basically. So this week we're going to do well. We're going to draw our map, and I'm going to let you think about it and tell me what projection you think we should use. We've already done something similar to this with our first map, and then next week we can use the same map and just we're gonna talk about the Southern Ocean this week and some of the geographic features. And oceans, even though it's a small ocean, it still has a lot of really cool stuff and a lot of really vitally important to our ecosystem, the world's ecosystem. And so we'll talk about that. I mean, it's a small ocean, but oceans, they play a huge part in our world, and lots of cool animal activity and stuff. And then next week we can just use the same map and talk about Antarctica. So or you can do two maps if you like, but it's going to be the same type of map otherwise. Now, a little known fact, the Southern Ocean has not been around since I was born. Or the waters have been around, of course, but they decided in 2000 to name it the Southern Ocean, because you can see, so when I was studying geography in high school and then in college in the 80s and 90s, there was no Southern Ocean. This would just be this right here. This is the tip of South America, so would just have been up. Oh, sorry, so touchy. This would have been the Pacific Ocean, the Atlantic Ocean, and the Indian Ocean. But they decided that it was important enough to give the world, the powers that be, to give the world a fifth ocean. So that's how the Southern Ocean was born. And we'll talk a little bit about why it deserves its own, what makes it different from those other oceans. Also, so let me see. So this is your assignment, and this is why I'm making this video. So I want you to think about it. These are some common map projections. The first one is the azimuthal projection. It's the oldest known record of this projection is from Ptolemy all the way back in 150 AD. He's kind of always thought as like the father of geography. However, it is believed that the projection is well known long before that time. Okay, we don't really need to know that, but today this is probably one of the most widely used azimuthal projection. Is mostly commonly used over polar areas, but can be used for small-scale maps of continents such as Australia. We did not use it for our Australian map. The great attraction of this projection is that the Earth appears as if viewed from space or a globe. This conformal projection in that shapes are well preserved over the map, although extreme distortions do occur towards the edge of the map. Directions are true from the center of the map. That means the touch point of our imaginary piece of paper, but the map is not equal area. So that means that the top of the map is true. It's going to touch the most amount of the paper if you place a paper on top of a globe and made your projection. So one interesting feature of the stereographic projection is that any straight line which runs through the center point is a great circle. The advantage of this is that for a place of interest, it gives an example of Canberra, the capital city of Australia, a map which uses a stereographic projection and is centered on that place of interest. True distances can be calculated to other places of interest. So in other words, you can kind of keep it proportional, and it's just great for places that small areas that you want to highlight. Okay, so the next one what we did last week. Wait, no, we didn't. We did the conic projection last week. Let's see, because we had the two standard parallels. So this comes from Johann Heinrich Lambert, who was a German-French mathematician and scientist. His mathematics was considered revolutionary for its time and is still considered important today. In 1772, he released both his conformal conic projections and the transverse Mercator projection. Today, the Lambert conformal conic projection has become a standard projection for mapping large areas and mid-latitudes. This is the one I think we should have probably used this for Asia, but we didn't, and we would have had a better chance. We used it for Australia. The projection commonly uses two standard parallels. So remember, we had our lines of latitudes, which are unevenly spaced concentric circles. The projection is conformal, and that shapes are well preserved for a considerable extent near to the standard parallels. So for world maps, its shapes are extremely distorted away from standard parallels. This is why it's very popular for regional maps and mid-latitudes. And distances are only true along the standard parallels. Across the whole map, directions are generally true. So this was our, we had the cone. That's what we used for Australia. And then the other one is the cylindrical projection, Mercator. And this is the one we used for the Indian Ocean. And you can see, you remember we had, it was wider the further away we got from the equator. One of the most famous map projections is the Mercator, created by Flemish cartographer and geographer Gerardus Mercator in 1569. It became the standard map projection for nautical purposes because of its ability to represent lines of constant true direction. Constant true direction means that the straight lines connecting any 2 points on the map is the same direction that compass would show. So we had pretty much coordinates that intersected each other with 90-degree angles, and they're straight lines. The distance was a little bit skewed, but they were straight lines with 90-degree angles. So okay, so that's my kind of summary of what that means. In an era of sailing ships and navigation based on direction only, this was a vitally important feature of this projection. The Mercator projection always has the equator as its standard parallel. Its construction is such that the lines of longitude and latitude are at right angles to each other. This means that a world map is always a rectangle. So also the lines of longitude are evenly spaced apart, but the distance between the lines of latitude increase away from the equator. This relationship is what allows directions between any 2 points on the map to be constant true direction. We don't really need to know the other stuff, but so it's just basically the three types: cylindrical, conical, and azimuthal. Sorry, I have a hard time. Azimuthal. So look it over, think about it, and tell me which one you think would be the best one.